Now we had two examples of sampling techniques with the dog example in the last slide, and we're going to investigate different techniques a little bit more in this skill set. So there are two types of sampling techniques that we're going to take a look at, so you start with a population, you choose a sample, and if that sample is non-random, then it's called a non-probability sample. And an example of a non-probability sample would be a volunteer survey or a volunteer sample. Now, often you're asked about that when you want to give a review of a restaurant or a hotel. That's a volunteer sample. Another example is a convenience sample. So that would be, for example, you want to find out who is going to the dance, and you just ask the people that you are standing out next to at your locker. That's a convenient sample of the entire population of your school. The other type of sample is a random sample, a true random sample, and that's called a probability sample. You can have a simple random. That means, like, for example, I'm going to ask every 10th person. Is an example of a simple random sample. You could layer them. In statistics, that's called stratified. So you're going to layer or group them and then make it random. So for example, you could say, all right, I'm going to ask every 10th person in grade 9, 10, 11, and 12. So you take all the people in grade 9, ask every 10th person. Take all the people in grade 10, ask every 10th person. That way you're grouping them, and you're going to make sure that way that you've got a good sample from the entire school. So stratified is a little bit more work, but it gives you a better representation of the population. So we're going to take a look at some scenarios and hopefully together decide what the characteristics are of the sample. So here's the scenario. The school district is considering a later start time at Stellies Secondary School, and they want to understand how the school community will react to this change. So the method they're going to use is they're going to send a questionnaire out with report cards with every student. So let's start by asking, what is the population? And the population would be all of the, it's this whole school community, so all the students, the teachers, and the support staff. So the bus drivers, the custodians as well. A sample would be, you're going to take a small group of those, that population, and in this case the sample is each student. So right away you can see that the sample is not a very good representation of the population because they're missing teachers and they're missing the support staff, and it is not random. So we're going down this branch here. It is a non-probability sample, and it's a questionnaire to be sent out with report cards. Sure, all of the students are going to get it, but are they going to return it? So it is basically a volunteer survey, because some parents will return it and some won't. So let's analyze that again through this circle here. Does the sample represent the population? No, it did not, because it was missing the teachers and the support staff. Somehow those would have to be included in the sample for it to be representative. Was the sample systematic, repeatable, and non-biased? Well, it was definitely systematic. There was a system to it, and you could repeat it every report card, I guess. And was it non-biased? Did it show favoritism? Well, it was biased because it was sent with the report cards. And not all students and parents have this read report cards, and so you're missing a group of the population, the ones that aren't paying attention to that. They're not going to be included in the sample. So if you get the results from the survey, will the results accurately reflect the entire population? No, because the sample was not a representative and there was a bit of favoritism. So let's take a look at the next scenario here. The Sydney police want to find out if drinking and driving, oops, missed the end there, and driving is an issue after the fireworks celebration on June 30th. So what they do is they stop every 10th car leaving Sydney after the fireworks, and they measure the blood alcohol level of the driver. So the entire population would be all the drivers attending the fireworks. The sample is every 10th car leaving Sydney. That's the sample. So they're not checking every car, they're only checking every 10th car. It is a random sample. So it is a probability sample. And it is, so it is a probability sample. It's random and it's a simple random. So does the sample that they collected represent the population? Yes, for the most part. I think there are always some exceptions. So one exception is that it depends on what streets. Did they block off all the streets and measure every 10th car, or did they just do that for the major thoroughfares? So, but generally, yes, the sample would represent the population. Was the sample systematic? Yes, it was. It's every 10th. Is it repeatable? Yes, they could do the exact same thing the next year. And is it non-biased? It is, because they're not just pulling over the cars that are the big pickups or the cars that have the N on them. It's every 10th driver, no matter what the conditions. And so do the results accurately reflect the entire population? The answer would be yes, and that's because the sample was a good representation and it was systematic and non-biased.